This is a video explaining a strategy that you can use for two-body motion problems. So this is an example from your textbook, question 24, where we have a car driving past a house at a velocity of 15 meters per second and a dog sitting outside the house who 1.2 seconds later decides to chase the car. The dog achieves an acceleration of 1.7 meters per second squared, and the question asks us how long until the dog catches up with the car. So in order to answer this question, we're going to make this first observation, which is really important, and that is that when the dog catches the car, the displacement of the dog will be equal to the displacement of the car. So what we want to do is we want to find an expression for the displacement of the dog, set that equal to an expression for the displacement of the car, and then solve for time. So the equation that we're going to use will be S equals ut plus a half at squared. Because we know the initial velocity of each object. The car's 15 meters per second, the dog's 0. We know the acceleration. The car has a 0 acceleration, the dog has a 1.7 meter per second squared acceleration. So we're just going to develop a little equation, an expression for the displacement of the car, first of all. Now, the displacement of the car will be ut plus a half at squared. The frame of reference that we're going to use for time will be the dog's frame of reference, because the question's asking us how long will it take the dog to catch up with the car. So the car is actually slightly out of sync with the dog. The car passes the starting point 1.2 seconds before the dog actually starts running. So the time for the car is going to be t minus 1.2. So S of the car will be equal to u, the initial speed, so that's 15 meters per second, times the time. So the time is going to be t minus 1.2 seconds, because the car's passes the dog 1.2 seconds before the dog actually starts running. Actually, the car's 1.2 seconds in front of the dog. So we're going to make it t plus 1.2 seconds. All right. Now the acceleration of the car is 0, so this second term is going to turn to nothing. So we'll do the same thing for the dog now. The dog's displacement will be ut. Now the initial velocity of the dog is 0, so this ut term is going to go to 0, and it's going to be plus a half times the acceleration's 1.7 meters per second squared times t squared. All right. So now we can say that when the dog catches the car, the displacement of the dog and car will be equal. So we're going to have 15t plus 1.2 times 15 is 18. So I've just expanded out this expression here. So 15t plus 15 times 1.2 is 18. That's the displacement of the car. And we'll set that equal to the displacement of the dog. So a half times 1.7 is 0.85 t squared. So now what we can do is recognize that this is actually a quadratic equation. We're going to just rearrange that so that we've got it in the form of a quadratic equation. 0.85 t squared minus 15t minus 18. So this is an equation in the form of ax squared plus bx plus c, where a is 0.85, b is negative 15, and c is negative 18. We can then use our quadratic equation to solve for t. negative b plus or minus square root b squared minus 4ac all over 2a. When we do that, we'll get an expression for time.